Let's talk about FOL semantics, meaning let's talk about what FOL sentences mean and when they are true. Now, you may recall that TFL is truth functional, meaning that in TFL, the truth value of complex sentences always is a function of the truth values of their component sentences. FOL is not truth functional in this way. So for example, if you think about the sentence all x are f, in this case, the truth value of that sentence is not determined by its component parts. In particular, the truth value of all x are f is not a function of the truth value of fx. Fx is an open formula, it's not a sentence, so it doesn't have a truth value at all. So that means that we need to find new tools. We cannot explain the conditions under which FOL sentences are true in just the same way as we did it for TFL sentences. And this new tool that we are going to use to define when FOL sentences are true are FOL interpretations. An FOL interpretation always consists of 4 things. First, we need the specification of a domain. I'm going to talk a little more about domains in a minute. Secondly, we need an assignment of a truth value to each sentence letter. So an FOL interpretation tells you whether sentence letter A is true or false, and so on and so forth. Thirdly, we need an assignment of exactly one object in our domain D to each name. So meaning each name needs to be interpreted as referring to one and only one object. Fourth, we need a specification of which things satisfy each predicate. That requires an assignment of a set of things in our domain to each one-place predicate, an assignment of a set of ordered pairs of things in our domain to each two-place predicate, and an assignment of a set of an ordered triple of things in D to each three-place predicate, and so on and so forth. So let's talk more about domains. What are domains? Domains simply are collections of objects. So for example, a domain may be the set of natural numbers. Or a domain may be just the items in my fridge. Or a domain may be Anna and Berta, and so on and so forth. So a domain may be any collection of things that you can think of. And sometimes we specify a domain by listing them all. So I could just list Anna and Berta and tell you that's the domain of the interpretation that I'm talking about. And sometimes we describe the elements of a domain. So I may say the domain of interpretation I are all the natural numbers, and then I don't have to list them all. My description, the natural numbers, is sufficient to specify the domain. Now, when we specify a domain as part of an interpretation, that means that we intuitively think of FOL sentences as describing the objects in that domain. So we think of FOL sentences when interpreted by a given interpretation as being about the objects in the domain that belongs to that interpretation. I used the notion of a set, and I also used the notion of an ordered pair. So let's say a little bit more about what those are. Sets, for our purposes here, simply are collections of objects. So say there's a set that contains only the items in my fridge, and there's also a set that contains only Anna and Berta, and so on and so forth. So sets simply are collections of objects. And we represent sets by means of curly brackets. Now, ordered pairs are similar to sets, or specifically they are similar to sets with two members, except that in the case of ordered pairs, the order matters, and that's why we call them ordered pairs. We represent ordered pairs by means of these edgy brackets. So for example, when I talk about the set that contains A and B and the set that contains B and A, those two sets are one and the same set. There aren't really two sets at all. The set containing A and B is the set containing B and A. However, the ordered pair that has A as first member and B as second member is different from the ordered pair that has B as first member and A as second member. And similarly for ordered triples, ordered quadruples, and so on and so forth. Ordered triples are similar to sets containing 3 objects, except that for ordered triples, the order of the members matters. Now, we can specify an FOL interpretation verbally by describing the interpretation. So here I'm giving you one example. First, the domain of the interpretation I is the set that contains Anna and Berta. Then I'm interpreting 3 sentence letters here, A, B, and C. I'm telling you that the interpretation interprets A and B as true, but C as false. And then in the third clause here, I am interpreting the 2 names A and B. So I'm telling you that A refers to Anna and B refers to Berta. And then in the fourth step, I'm interpreting the predicate F and the predicate G. So I'm telling you that the predicate F applies only to Anna, and the predicate G applies to the ordered pair that has Berta as first member and Berta as second member. So that's one FOL interpretation. You may notice that I do not have to interpret every sentence letter or every FOL predicate or every FOL name. So here I'm only interpreting 2 FOL names and 2 FOL predicates. So which names and predicates you interpret depends on the context. You only need to interpret those names and predicates and sentence letters that matter for the exercise that you are engaging in. Now, sometimes it is useful to supplement the verbal specification of an interpretation by means of an image. So in this case here, I'm showing you how to specify an interpretation using both a description of that interpretation and a picture. So in this case, the domain of my interpretation includes all the objects in the image. I'm not interpreting any sentence letters since they are not relevant for my purposes here. There are a number of names that are interpreted as in the picture. So for example, the name A refers to the little tetrahedron all the way to the left. So interpretations of names are as assigned in the image. And then I'm telling you that I'm using the capital letter C to express the property of being a cube. So the interpretation of C is the set that includes all cubes. And the interpretation of the capital letter T includes all the tetrahedra in my image here. And the interpretation of the predicate D includes all the dodecahedra in my image here. So here I've used a combination of an image and a description to specify an FOL interpretation. Furthermore, sometimes arrow diagrams can be useful for describing an interpretation. So here we have an arrow diagram on the right-hand side, which indicates a specific interpretation. So the domain of this interpretation contains the 4 numbers 1, 2, 3, and 4. We again have no relevant sentence letters, so no sentence letters get interpreted. We interpret numerals as expected, so we use the numeral 1 to refer to the number 1, and so on and so forth. And then we have a predicate R, whose interpretation is represented by means of the arrows. So in this case, you see that the interpretation of the R includes a number of ordered pairs. It includes the ordered pair that has 1 as first member and 1 as second member. It includes the ordered pair that has 1 as first member and 3 as second member. It includes the ordered pair that has 3 as first member and 1 as second member. It includes the ordered pair that has 3 as first and as second member. And finally, it includes the ordered pair that has 3 as first member and 4 as second member. Okay, so we have talked about FOL interpretations and different ways of specifying interpretations. And next we are going to talk about what it takes for FOL sentences to be true on a given interpretation.